Hello, I'm Isaac Ajao. I want to introduce statistical inference using Python. Now, this is Python. Statistical inference is a method of making decisions about the parameters of a population based on random sampling. It helps to assess the relationship between dependent and independent variables. We have various type of statistical inference. There are different type of them. And the reason why we have to do this is because the decision have to be made. Even after we have analyzed our data, we have to set some rules. Are you rejecting your H naught or you do not reject? So we have type of statistical inference. Some of them are one sample hypothesis testing, confidence interval, bivariate regression, multivariate regression, even pi-square, Pearson correlation, chi-square statistics, and contingency table, analysis of variance, one-way, two-way, factorial experiment, or theta. Essentially, whenever we are analyzing a data and we have to make a decision, that is statistical inference. You must infer to whatever thing we get. So that is it. Now, we want to move on. So to carry on or to do this in Python, we need to import certain libraries. NumPy, matplotlib for plotting. Now, I want to generate some data values in the data set. The way I'm going to do this, I'm going to come up with population data. I also generate sample data just to explain what I'm trying to say. Now, population from this line of code, I want to explain this. I want to generate random number because without, you can see where I put here population sample and sampling distribution. I want to do it population first. So the random number values I want to generate. See, I want the center to be at 50. What we can call the mean. Center of the because it's not easy getting a perfect normally distributed data. That's why I'm using a method of generating it. Now, I want you to follow a particular pattern. The log you see here is 50. That means the center. So the center of distribution is at 50. This scale 10 you see, that is standard deviation. So it will be plus or minus 10. Then the size is 10,000. I want 10,000 values to be generated. So I'll try to explain this. So standard deviation, scale of 10. The spread or weight of the distribution is determined by the standard deviation. That is spread. That's the variation. So here, standard deviation of 10 means that most value will fall within the range of 40 and 60. This is the range. 50 plus or minus 10. That's the meaning of this. So by the time we take the mean of this particular generated value, this population, it will fall within 40 to 60. Now 50 minus 10 or 50 plus 10. Now let me build this so you can see. So the population I've generated here, you can see 47, 49, all of them like this. So this population is going from 47.65 to the last one here. You can see 47, you can see 56. It's still within the range. You can't see 70 here because we are seeing the range is plus or minus 10. So we normally use this when we want a normally distributed data. So this is sample data now. Of course, sample will not be as much as population. So here we have the sample. The same what I use here. Though it's not only Python we can use to generate or simulate data. You also use R. Even Excel can do it. It all depends on our choice and what we want to do. Now, this random does, what it does is that it just picks randomly, but we have given it a range. And normal means it's coming from normal distribution. Same thing with sample. So you can see choice here, population size 100. You can see. Then replace false. This replace false means you do not replace any value within the generated data. Now you want to print this. So the mean of the population, this population, I want to find the mean of this population. You know, it's just like the reason why we are using NP, just like we normally use PD for pandas. We use NP for NumPy. So anywhere Python sees this, NP has been defined here. That's how libraries work. We have to bring what we have defined up there to be used anytime I want to use it. So now it's going to pick, the choice here is going to pick the sample from the population here. So it means without population there can't be sample. You must have targeted a particular population, because before you can now say I'm going to pick from that. So we are picking 100 from population of 10,000. You can see. So to print this, so they want to print the population mean, then the sample mean. We have generated sample from population. So let's now check. The mean must be very close. If the mean of the sample is too far away from that of population, something is wrong with that sampling. And to get it wrong, start from sampling. Anything you want to do under statistical inference, want to do an analysis, and the sample mean is far away from population, such sampling is erroneous. So you can see population mean here is 50.04. Sample mean is 48.8. This one can be approximated to 49. This one is 50. Very close. You can see it's a very good quality, and it means whatever thing you want to use this, whatever value we get in our analysis using this sample will be a true representative of what the population will see. That's what it means. Sampling is very important in statistics. We don't play with it. That's why we have to test all of this. Now I want to plot the population and sample distribution for us to see. This PLT is coming from this library. Anytime I want to use it, we use PLT. I want to draw this. I want to see the visualization of a population and sample distribution. So the figure size is 8 by 6. That is 8 inches by 6 inches. 8 by 6 inches, you can see. Now this one will be the width and the height. So now we want to plot an histogram. That's why you have HIST. Then the pins, this is the width of the bars. Color will be blue. Then the label will be population. Then the title is population distribution. This can be changed. Anything you want to put here. These are just by decorating the bars. The most important thing here is for us to get the plot figure. So let me build it. Let's see. So this is the blue. The blue here. If I change it to red, it will change. Red. Red. You can see. So then the value, you can see value here. Frequency for Y level is here. So the same thing with this plotting sample now. We want to plot the sample. Sample, don't forget, the sample is from population. And look at the center here is 50. Look at what we specify. We say 50. So the chart has already shown it. This is the center, 50. And we say plus or minus some values. We have seen it here. Now let's build that of sample. So you can see it's scanty because it's sample. Look at where the 50 is. Sample is always very small. So now we want to put legend. I'm looking at legend here. Let me see. True. True. Yeah, true. So if it's part of the, it's not allowed. So such we not allow it. Such chat doesn't allow legend. So let's leave it as it is. So we're gonna change all of this, change the name to work for us. Now we have generated 10,000. I want to bring them together now. I want to bring this population together with that of the sample by using subplot. Subplot means you want to create a chart inside another chart, or let them come together. So save space, and they can stay side by side. And the first one will be first subplot, while the second one will be second subplot. So we can see here it follow row column index. So this is what I put here. The rows here is 1, and the column is 2. So the 1 here is the first subplot. You can put it here for multiple plots in a single for comparison purposes. So data with 50 bins, color and 70% opacity. So 70% here is alpha, that's 0.7. So here we can bring two. This one is also it can be done this way in MATLAB. You can see if you use laptop, MATLAB, they look alike. So when you have many charts, you don't need to be on the same on different pages. They can be brought together either side by side or following one another on the same page. So add the second subplot. You can see the sample is here. The population is the first. Why? I'm trying to bring plot of a population and that of sample together on the same page. So what I need to do now is what I put here is the same thing. It's the only thing that's bringing them together is the subplots. So, and this one is the first one. Second one is 2 here. And the color here is green, color here is blue. Just like the way I did it. I have not done anything new. Then I want to display the plot. This one, this plc.tight layout will bring them together and then we show it. You can see side by side. You can see the 50 here, see the 50 here. So this one saves space. When you're writing paper and you are just showing all of your charts in different pages, it may not be allowed to save cost and their papers. So we do that a lot. Then there are some rules under probability which I've shown here that we normally do in statistics. Probability basics. This is how we do it. The probability of A is 0.5, probability of B is 0.3. So we can bring this together, just like mathematics. I just try to show this. When your probability of A is 0.5 and probability of B is 0.3, add them together, we just give us 0.8. What we are doing mathematics, I just try to show this because there's no where we do distribution that will not talk about probability. And what is doing this is the skipping of statistics. Whenever you want to do this, it works for it. That's what I've done here. So when you add them together, you're going to give us 0.8. Multiplying them together will give us 0.15. Python doesn't allow space, so that's why we use underscore. And the same thing rules here we use here. Probability of A or B. So probability of anywhere you see A like this, or you are referring to plus. That's to add them together. And this is the rule in mathematics. So this is what we call when you assume independence, that means they are not related. So, and we print this. So when you say probability of A or B, it will give us 0.65. You are deducting that of a probability of A multiplied by a probability of B from the addition, give us this. Now the last one I want to explain to us is probability distribution of normal, using normal distribution. We have what we call standard normal. The mean should be 0 and standard deviation should be 1. The mean here, we say is 50. 50. I see 50. But here, when it is standard normal, we are standardizing our values. So the mean will be 0, standard deviation will be 1. So here, what we are doing, okay, let me explain what is the meaning of this before I now show us on the chart. The standard distribution is a special case of normal distribution. Look at it, standard normal. Special case of a normal distribution, which is a continuous probability distribution. We have some other distribution in statistics that are not continuous, that they are discrete. So, but normal distribution is one of those that are continuous in nature. The standard normal distribution is characterized by the following properties. The mean of normal distribution is 0, and the center. This is the center of distribution, and it is where the peak of the curve lies. Let me build this for us to see what I mean. Let me explain this code before I go to that. So the standard deviation, we are defining mean to be 0, standard deviation to be 1. We are still using numpy, np dot length space. So -3 to the left and 3 to the right. That means the lowest here will be -3 and the highest will be 3. How many? What's the size? 100. So now I want to have our y. These are our x axis. These are y axis. So you are using the mean to be 0 and standard deviation to be 1. So this is going to generate 100 random values here. I want to print it. Okay, start is not defined. Let's define it. Define it. I've defined it. So see, the x values start from -3. See, that generated 100 values for x, from -3 to -2 to all of to the last one is 3. And y now, which follows this one start from 0 to 1. And see, look at it, 0.000 to the last one, which is 1. You can see 1 around this place. That one will be 0.9 something. When you look at it very well, you will see it. The highest we see here is 0, it will be 1, and the smallest will be 0. That's what we are talking about. So here, the standard normal distribution, as I was saying, this is the PDF. Look at the shape. Look at standard deviation sigma. So the standard deviation measures the spread of the distribution of data around the mean. That's the other time I said 50 plus or minus 10. So it measures the deviation around the mean. See, that's very, very important. And this is the PDF of the continuous distribution. We call this PDF, or some people just call it density function. So PDF here is the standard normal distribution. All of the distribution in statistics have their PDF. So the x represents the point of horizontal axis, so the base of the natural logarithm. So this is the z-score. This is applicable. You can see the standard normal distribution mean of this. I've explained this. Now here, application. The application, there are many. I'm just giving us this few three. Hypothesis testing. We also use in confidence interval to construct confidence interval to take our decision. Though these days we are fond of using p-value. Statistical process control. This one is used in quality control. So this is where we use it. We have 3 sigma, we have 2 sigma. Standard normal distribution about this is 68.27% of the data. When it falls within one standard deviation from the mean, then when you fall between 2, plus or minus 2 from the mean, you're talking about how standard normal distribution work. So these are the properties. So let me show it to us before I move away from this. So we want to plot this particular normal distribution to show what we're talking about. So this is it. This is minus 3 to 3. You can see. So very simple. You can see. And the center here is 0. This is a good example of standard normal distribution. Let me change this. Standard normal distribution. So this is it. So next class we'll talk about hypothesis testing and analysis of variance. Thanks for listening.